All right, so believe it or not, this is an Arduino project. So I thought I'd demo one of the bigger projects that I've done with students. So this is an electric mandolin that we created in the manufacturing class, and it's got a single coil electric pickup, much like what's in a Fender guitar or classic basic electronics for musical instruments. So there's a single coil pickup here, which looks like this, and there are approximately 8,000 wraps of number 42 copper magnet wire on this. So as you can imagine, getting a student to hand wrap 8,000 wraps of wire that is thinner than a human hair around this is a little bit problematic. So to make life a little bit easier, a few years ago I created a pickup winder using an Arduino and an Arduino motor control board to help me with this. So the first iteration of this, I used an Arduino Uno and a basic motor control board, and they're still available. And I used the debug screen to display the count. In subsequent ones, I've actually done LCD display. So hopefully you can see this. I'm gonna pick this up and hopefully show you. So this is an Adafruit feather. So this board, and let me see if I can get a little closer to the camera here. So this is the feather, which is an Arduino board. This is a motor control board, so I can control higher voltages and currents with the control signal from the Arduino. And then this is an LCD display. And hopefully you can see this as I'm rotating the bobbin, you can see the count going up on the LCD display, counting 1, 2, 3. So how does that happen? Well, let me put this down and show you another little device. So this device is an opto-isolator, and it's a component that is used in things like encoders, like we would see in robotics, to count pulses and a signal for motor control. So on one side of this, there's an infrared LED, and on the other side of it, there's an infrared detector. And so when the light is on, it'll shine a signal to the detector, and when it's off, it won't detect it. So essentially what you're doing by detecting the light, you're creating a 0 or a 1, an on or an off. And these are pretty simple to use. The one side is wired just like you would an LED, so you'd have a current limiting resistor on it. And the other side is also very basic and also wired to the LED so that it acts as a switch. So wired to the Arduino so it acts like a switch. So there is a resistor, a high ohm resistor, so it will, on this, if I remember right, it is created to pull the signal low, I believe. And so I created this little mechanism with this opto-isolator, and it's got a little hole, so the LED, the infrared LED is on all the time. There's a hole in this, and as the hole passes by the opto-isolator, it lets the light in, and it detects the signal, and it counts. So it's very basic. So how do you start doing something like this? Well, I started out with trying to understand how to wire the button switch. So there's an example program in the Arduino, it's called button. And essentially what happens is when you press the button, LED goes on, and you stop pressing it and the LED goes up. So that's the same thing as a switch. So this infrared detector acts like a switch. So that's the basic premise. So from there on out, you use it by creating a variable in the programming so that when it detects that, it increments the variable and it creates the count. Going further on this, you can use the debug display on the Arduino software, so you don't actually need to have an LCD display. You can use the debug display and view what that count is. Now, the nice thing about using an LCD display like we've done here is that it displays this right on the board. So that's the basics. So the need was I had to wrap 8,000 wraps of magnet wire, and the solution was to use an Arduino with a motor control board, and this is all fairly compact. I think all in all I have about $80 tied up into this, and this motor that's in here is a one I scavenged out of an old power drill. And so very basic stuff, and then the plastic parts were designed by me in rapid prototypes. So the Arduino was a solution to a problem I had.